Okay, everybody, today we are going to talk about sequences and series, and hopefully we can get through this entire topic in one video. If not, I'll make a second video and we'll go with that. But I'm going to try to once again keep this video to within your class time so that you can hopefully watch it in a class, and then we'll go from there. So what's a sequence? So a sequence is just whenever we list a series of numbers. Well, I'm going to try not to use the word series. Okay. So, oops, sorry, 13. I've got the sequence 1, 1, 2, 3, 5, 8, 13. ... And this is a special sequence, or by the way, it's called Fibonacci sequence. So if you haven't seen it before, it's a special kind of sequence. It does have a lovely pattern to it. So we can figure out the next couple of terms in the sequence, which is one of the things we will often ask you to do, is figure out the next couple of terms. But it's an unusual pattern. This particular pattern is add the two terms, the first two terms together. 1 plus 1 gives me 2. And then add the next two terms. So 1 plus 2 gives me 3. And then add the next two. 2 plus 3 gives me 5. 3 plus 5 will give me the 8. 5 plus 8 will give me the 13. And so the directions will often say, find the next two terms in the sequence. That's a lot of times you'll see something like that. Sometimes it's 3 terms. Sometimes it's just the next one term. Okay. So if you're following that particular pattern, then hopefully you see the next one is 8 plus 13. Excuse me, and that'll give you a 21. So the next guy is 21. I'm out of space. I shouldn't have written that there. Sorry. But the next term would be 13 plus 21, these two, right? And that would be what? 34. Okay. So I'll stick it here, 34. Okay, so these would be the next two terms. Okay, so sometimes we can see an interesting pattern like that, but other sequences are just like, for instance, 2, 5, 8, 11, 14. And we need to give you enough terms of the sequence, enough of these elements that are in there, that you can look at them and you can see the pattern. So hopefully if you look at these, you see a pattern coming out. It's not add the two terms together, it's add 3, right? 2 plus 3 gives you the 5. And then from this term, add 3. 5 plus 3 gives me the 8. And then from this term, add 3. 8 plus 3 gives me the 11. And from this term, add 3. 11 plus 3 equals 14. Probably if I've added the same number 4 times now, then that is the pattern, right? It's not going to suddenly deviate, especially when they give me a ... So again, I can just kind of do this math and set it up. So if I wanted the next term, it would be 14 plus 3, and we know that's 17. So we could get that term. I'm going to do 2 because that's what the directions up there were. And then 17 plus 3 would give me 20. So that when I stick these numbers, these terms in line like this, we can go ahead and do what we did a minute ago and say, is it the plus 3? Yep. Is it the plus 3? Yep. So the pattern just continues. Okay. So these that have, so this one at the very, very top, I said that one's a special guy. His name's Fibonacci. It's named after a guy named Fibonacci. You can look him up. It's actually kind of an interesting pattern. And he was looking at reproduction processes of rabbits. So that's its own special guy. But these where we just add the same guy over and over and over again, the pattern is add 3. These are called arithmetic sequences. Okay. And I kind of keep that in mind because arithmetic involves adding. And I know it looks like arithmetic, But for some reason, when we talk about sequences, we put the emphasis on the wrong syllable. So it's syllable. Yeah, it's arithmetic is the way they say that. So these have to do with adding. So there's one more type of sequence and it happens pretty regularly. And I'm going to say, let's start with 4. And this guy right here, the first term, we're going to talk about those. Those are considered, they're called your initial terms a lot of times. So I'll come back and get you some vocabulary for these. But this start with 4 and let me show you. The next one's 8, the next one's 16, the next one's 32, ... So can you look at that real quickly and tell yourself or tell me what's she doing to the 4, the initial guy, what operation is going on to get to the 8? And I'm in my head, I'm hoping you're saying, well, you either added 4, right? Or you multiplied it by 2. But if it was add 4, then the next term would be a 12, right? And it's not, it's a 16. So I'm going with times 2. So 4 times 2 gives me 8. 8 times 2 gives me the 16. 16 times 2 gives me the 32. And again, if you can do the same operation multiple times in a row and you're still getting the next term in the sequence, then probably we have identified what our pattern is. So I'm going with a times 2 here. So if that is the truth, then let's figure out our next 2 terms because that's what we're after, 2 terms in the sequence. 32 times 2 is 64. I'm hearing you say in my head. I know I have a lot of voices in my head. So 64 times 2 would be 128. Okay. And then the pattern continues and goes on, right? So this is a slightly different thing. On these, we were adding. Now we're multiplying. So it just happens that anytime I'm multiplying, we call those particular sequences geometric sequences. Okay. And that goes along with multiplication. Okay. There can also be exponential sequences and stuff like that, but the 2 that we're going to focus in on for this class are arithmetic and geometric. Okay, so first, just a little bit of nomenclature and getting you into what we're talking about here. You can have finite sequences or infinite. Finite or infinite sequences. Okay, so just some verbiage so that we all know what we're talking about vocabulary wise. So finite, well, everybody I think probably knows what infinite means, right? Infinite in everyday speak, we might say infinite goes on forever, right? Okay. The ... So each of the ones I've given you, each of these 3 sequences is ... 1, 2, because I said ... We're going to go on forever. Okay. So that's an infinite sequence. And I think most people are good with that word. The word finite, though, sometimes people don't quite know what that means. So let's look at that. Okay. And the way I look at it is it has a definite start and a definite end. Okay. So like for this sequence here, I have a definite start. That's this 4. It's the first term, the initial term, but I don't have a definite end. And that's what makes this guy infinite, right? But what if I gave you the sequence 5, 10, 15, 20, 25. And that's it. That's the sequence. Okay. Well, we can talk about that we're looking at multiples of 5 between 5 and 25, and we're including the 2 endpoints, right? And that's all good and fine. If I had, instead of stopping, if I had said ... and I had gone to 90, 95, 100, okay, Even though this has the dot, dot, dot in there, okay, it's called an ellipse. Okay, even though that has that dot, dot, dot in there, it is still a finite sequence, okay? And the reason it's finite is because it has a starting point. When we stopped here, our ending point was 25, right? So I had a starting point and an ending point, okay? But here I have a starting point and this ending point because I extended my sequence out till 100. So now we would talk about multiples of 5 between 5 and 100, still including our endpoints, okay? But whenever I look at those, I see that dot, dot, dot in that, and that kind of gives people a little bit of a wait a minute moment, because before we've seen the dot, dot, dot at the end, and that has meant that we just go on forever, right? This dot, dot, dot just means, I hope you see my pattern that I'm doing multiples of 5, but I am not going to list all the ones between 25 and 90. Okay, so we know there are terms in there. We could count them, okay? This number of terms I could count. If I stopped at 25, it was only 5 terms. But here I have a bunch more terms, right? So I can figure out how many terms are in there, but I can count them, okay? Infinite, I can't count them, right? They just go on and on and on and on and on. So there's no stopping point. So that's the difference between finite and infinite. I hope that makes sense to you, okay? The way we write sequences, so you've seen I'm writing the terms, we just go this one, then this one, then this one. But a lot of times we'll have a special notation. This is where people start getting a little confused. So I don't want you to be confused. A1, A2, A3, A4, dot, 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 okay? Where A represents a term in a sequence. Okay, just means we're going to be talking about a sequence. When you see A sub 1, that's how we say it. A subscript 1, A subscript 2, A subscript 3. Some people just say A1, A2, that's fine. Okay, it's not the same as an exponent though, right? The exponent goes up on the top. These are on the bottom, they're below, so they're called subscripts. So when I see these and they've got these subscripts in them, A represents a term in the sequence, and the subscript tells me its position. Okay. The subscript tells me the position. So in this case, A sub 1 is the first term. That's what that means. A sub 1 is the first term, okay? And a lot of times, like I said a minute ago, you'll hear it called the initial value or the initial term, okay? That's where we started our sequence. That's what that means, okay? So if I asked you what A sub 5 is in this sequence right here, A sub 5, okay, then hopefully you would go, well, 5 is the first one, 10 is the second one, 15 is the third one, fourth one, fifth one. A sub 5 here is 25. Okay, so it just tells you what place it's in. By the way, I didn't ask, is this going to be considered an arithmetic or a geometric? Remember, arithmetic up above, arithmetic is adding, geometric is multiplying. So we know it's multiples of 5, so I just kind of skipped it, but just to make sure we know. To get from 5 to 10, you can do 2 things. You could either multiply by 2, or you could add 5. So we need to know which one it is. Is it multiply by 2 or is it add 5? Well, if it was multiply by 2, I would have 5 and 10, but 10 times 2 would give me 20, right? I wouldn't have this 15 guy in there. And 20 times 2 would give me 40, so I wouldn't have that 25 guy in there. So it is not multiply by 2, it is plus 5. Plus 5, plus 5, plus 5. So I see that and I say, oh, this guy's arithmetic. So hopefully you can start just looking at them and you can tell the difference, right? And I always ask myself that, what I just asked you, what did I do to the first term? What can I do to 5 in order to get to 10? Okay, and there's other more convoluted stuff that you can do. For instance, I could say multiply by 3 and subtract 5. If I multiplied 5 times 3, I'd get 15 and subtract 5. That'd be okay. But does it work here? 10 times 3 would be 30, way over here. 30 minus 5 would be 25. So no, it doesn't work there. So you have to go, it needs to work for every term in the sequence, right? So if I'm doing this kind of thing and I'm like, well, it worked for the first term, that's not enough. You have to see a pattern. It worked over and over and over and over. Once you see the pattern works multiple times, then you're okay. All right. So there could be several things I could do to 5 to get to 10, but only one that gets me from 10 to 15 and from 15 to 20 and so on. So it's got to be plus and it's got to be arithmetic. Okay. So this is what the notation looks like. So you might see them talking about a sub n, for instance. Okay. Well, a sub n is a little bit different. What the a sub n means is the nth guy. Okay. So here's one. Let me give you an example. A sub n is equal to, we're going to say 3n plus 4. Okay. A sub n is equal to 3n plus 4. And what we want to do is just write the first 4 terms of this sequence. Okay. So I'm going to scoot this a little bit. All right, so a sub n in this case, this means n is the number. Okay, n stands for number of the term. So again, this is its position. So where people start getting mixed up is the number that is in the spot versus the position it's in. Okay, so I'm going to show you what I mean. They want me to find the first 4 terms. That's the directions for this. Find the first 4 terms. Okay, so it's going to look like something, comma, something, comma, something, comma, something, dot, 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 right? But they want me to find the first 4. Okay, so this position right here is the first position, and this is the second position, and this is the third position, and the 4th position. So if I was talking with subscripts, this guy that's in here would be my a sub 1, and this would be my a sub 2, and this would be my a sub 3, and this would be my a sub 4. So the subscripts tell me which slot I'm in, basically, in my whole entire sequence. But the guy that's in that position is not going to necessarily be a 1, right? So we need to find the term. So when it says find the term, okay, the term is the number in the position. Okay, I think of them as like this is a placeholder. Okay. So the term is the number in the position. So that's the difference, and that's how you're going to read this stuff. So let's do it. Let's find a sub 1. This is the first guy, right? A sub 1 equals. Well, if the n is 1 here, then the n in my formula has to be 1 also in the equation. So what that's telling me is substitute in 1. Okay. So 3 times 1 plus 4. If the subscript is a 1, then that means my n is a 1, and that's what I'm plugging in. Okay. So 3 times 1 is 3 plus 4 is a 7. The first guy is a 7. Okay. They asked me to find 4, so I'm going to do a sub 2. Again, my subscript is a 2. That means I'm plugging in a 2. So I'm looking for the guy in the second position. Okay, and when we do the math here, we see 3 times 2 is 6 plus 4 is a 10. I'm going to scoot this up. Hopefully everybody's written all that stuff down. Okay, when I look for the third term, my n is a 3. 3 times 3 plus 4. 3 times 3, oops, no parentheses there, sorry. 3 times 3 is a 9 plus 4 is a 13. Okay, and my fourth guy here, I'm going to substitute in a 4. 3 times 4 plus 4, because that was my original equation here. So 3 times 4 is 12. 12 plus 4 is 16. All right. So I've got my 4 terms. Okay. The first term is a 7. So I'm going to fill in my blanks. 7. The second term is a 10. The third term is a 13. The fourth term is a 16. So I'm going to rewrite this down here so we can see it. So here's my sequence. 7, 10, 13, 16, ... Okay. That doesn't have to be my last sequence, my last term in the sequence, right? So unless they told me it was finite and it stops on the fourth term. All right. So I'm looking at this and I'm like, okay, so we had this. This is a linear equation, right? The exponent on the n is a 1. That means it's not quadratic, it's not cubic, it's just linear, okay? So when I look at that guy and I say, okay, I've got a linear equation going there, I didn't necessarily look at this original equation and say in my head, that's going to be arithmetic, okay? But now that I've got my sequence listed out like this, now I'm thinking, hang on a second. 7 plus 3 gives me 10. 10 plus 3 gives me 13. And 13 plus 16, I'm sorry, plus 3 gives me 16. So it looks like I'm adding 3, okay? And if I'm adding 3 to get each term, then the next term would be plus 3, would be 19. And so on and so forth, okay? So if I'm doing that, then that means that this guy is arithmetic, because I'm adding. My pattern is to add 3, right? Okay. Oh, that pen is dying on me. I think that pen dies on me repeatedly. Okay. Arithmetic. So I'm looking at that going, let's check it and see if I can substitute it. This is the what? 1, 2, 3, 4, 5th term. So you have to keep 2 different things straight in your head. What position I am in, what term number am I on, and what is the term that's holding that position. So 1, 2, 3, 4, 5th position, we think it's the 19. So right over here, I didn't leave myself any room. I'm going to put it right here. A sub 5, we think 3 times 5 plus 4 is going to give me a 19. And sure enough, that's 15 plus 4, 19. Absolutely. So check, it works. Okay, so if you pay attention whenever you're doing these arithmetic things, this number right here on an arithmetic sequence like this is going to be the same as this number right here. Okay, so if I was looking at this as a linear equation, that would look like y equals mx plus b, and that would be my m. Does everybody agree? Okay, so this number right here is going to represent my slope. Okay, it's the difference between the 2 terms, but it is the slope. So if I put these points in on an equation or on a graph, let's just do that real fast. I'm not going to connect them necessarily, but I've got the point 1, 7, and 2. The second point is a 10, and the third point is a 13, right? So I'm just going to kind of dot it like that. It looks like it's a linear equation if I connected those dots, right? And sure enough, it is, because we started out with 3n plus 4, right? The difference is we wouldn't have x here. I'm sorry, it would be an n, and this wouldn't be a y, it would be an a sub n. Okay, but same kind of thing going on. It's still my input and my output, so we're good there. Okay, so these all kind of tie together with what we've already talked about, is what I want you to know. So when we go to figure out, for instance, an arithmetic sequence, sometimes we need a little bit of help. So sometimes we use a little formula. So let me give you that guy. I've got to find him. I'm sorry. Here it is. That is not it. Give me just a second. Pause. Okay, I found my formula. Okay, so if you want to know the nth term of the sequence, for the nth term of the sequence, which, by the way, just means I can pick any term I want. Okay, if I have this generic formula here that we're going to use, I can find any term I want without having to do plus 3, plus 3, plus 3, plus 3. We don't mind doing plus 3 if I'm only going for a couple of terms. But what if they had said, instead of find the next term, what if they had said find the 20th term? Well, I've only got 5 here. Okay, so I'd have to find 15 more terms, and that's going to take me a while, and I don't want to do it like that. Okay, so instead, what I'm going to do is I'm going to find the nth term of the sequence by using this formula. A sub n is equal to, and what you do is you find your first term. That's why I said your initial term is going to be important for us, a sub 1. So you're going to find that initial term plus n minus 1 times d. And I'm going to tell you what that stuff means. Okay. This is the nth term. This is my initial term, right? A sub 1. Okay. N, we already figured out what the n is. That's the number of the term, right, that I'm looking for. Or you can think what position it's in. What slot is it holding? So the D is the one that we're not really sure of. The D is the common difference. So you do have to pay a little bit of attention like we did above. You have to say, what is the difference between these guys? Okay, so if I can find the common difference in there, which we already did, it's plus 3, right? Then, okay, let's go ahead and plug that in and see what we can get. So let's find the generic for this guy. Okay. A sub n, that's going to stay generic. A sub n equals, what was my a sub 1? The first term. Okay, the first term here was a 7, right? So we're going to put it in a 7 plus, let's leave this generic for right now, and in a minute we'll find the 20th term, okay? So n minus 1 times d, and we said the d was the 3, right? Because the difference is 3 each time. All right, so this is my generic formula for the nth term of the sequence. Okay, so I've got that. And by the way, if you multiply this out, you'd get 3n, and you get a -3, and -3 plus 7 ends up being the plus 4 that we started out with, right? So 3n plus 4, they are equivalent. That's the important part for us here, okay? So I said, let's find the 20th term. Once I have this in this form, okay, because it's a nice, pretty closed format, I can say a sub 20 equals 7 plus 20, because I'm looking for the 20th term, minus 1 times 3, right? So the 20th term is going to be 7 plus 20 minus 1 is 19 times 3. Oh man, I shouldn't have picked such a big number. What is that? 57 plus 7. So the 20th term looks to me, check my arithmetic, but it looks like it's a 64. Oh, sorry. Looks like it's a 64. I think that math is right. So just check my arithmetic and make sure I didn't go off path anywhere. If I did, I apologize, but I think I'm okay. Okay. All right, so that's my 20th term. So I can do that anytime I want, and we're going to use that formula. Okay. Let's find one. And then I'll show you one more notation, and then we'll get a formula for geometric, and I will be very, very happy if we get that far. Okay. So here we go. Find the 8th term. This is an example out of your book that I just stole. Okay. Find the 8th term if, okay, so they're not giving me the sequence this time, they're telling me stuff about the sequence. If the first term is 4, and the common difference the common difference is -7. Okay, and I left it off, but this is an arithmetic sequence, so we should be able to use the generic formula we just had up here. So again, just for funsies, that formula is a sub n equals a sub 1 plus n minus 1 times d. So let's see if you can plug those things in and figure out what is your what's your formula, first of all, and then second of all, what is your 8th term. Okay, so I read the first term is 4 and I say, oh, that's my A1. So hopefully you're putting that in. If you need to pause this so you can play with it a minute before you listen to me, then go for it. It's not a problem. Okay, so a sub n is going to be the first term here is a 4. And then what term are we after? Well, I'm going to leave this generic for now. N minus 1. And what's the difference? A -7, I'm hearing you say, right? Okay, so I'm going to go ahead and a sub n equals 4. Okay, let's go ahead and multiply this through. Just it'll simplify things, right? -7n and a negative is a +7. So this guy is going to be my generic term, -7n. I'm going to move that to the front, and I've got a 4 and a 7 plus 11. Okay. Now find the 8th term. So a sub 8 equals -7 times 8 plus 11. So I went ahead and distributed it the -7 because I thought, oh, it'll look nicer, right? This is my generic form, so it's easier to plug into. So -7 times 8, -54, I'm hoping, right? Oh, not 54. Hang on, sorry, 56. Dang it. Hang on a second. Yeah, 56. 7 times 7 is 49, plus 7 is 56. Okay, so sorry about that. I had a bit of a momentary mind glitch. Okay, and then a plus 11, those are opposite signs. So I'm going to take the sign of the bigger number, which is negative, but then I subtract, right? So 6 minus 1 is 5, 5 minus 1 is 4. So I'm getting a -45. Okay, why is it suddenly negative? Okay, let's think about that for a second. They said my difference is a -7, and we didn't talk about that at all. So I'm getting a -45. We started at 4, but we went -7, -7, -7 for 8 terms or 7 terms to get to the 8th term. And I'm hearing it's a -45. So let's just check real quickly and think about it. The a sub 1 should be 4. Let's check that we got the right number. Oops. Oh, sorry. Times 1 plus 11 gives me -7 plus 11, which is the 4. Okay, we got the right number there. Okay, and let's look and see, let's do the second term, because when I do the second term, -7 times 2 plus 11, I get negative 14 plus 11. I'm already negative 3, right? Okay, so the second term is negative 3. The third term minus 7 is going to be negative 10, and so on. So I am seeing that I'm going to be a negative in all my answers, and it's going that way quickly. This was a 1. Sorry. Kind of scribbled on that. Sorry about that. Okay, so then in that case, yeah, I'm okay with it being the negative whatever there because it makes sense. Okay. The second thing that we're going to have to do whenever we're talking about arithmetic sequences is we might have to sum them. Okay. The sum of a sequence is called a series. Okay, so when I started this, I said sequences and series. So the series part comes in whenever I do summation notation. Okay, whenever I sum these guys up. So what we're seeing is, for instance, let's come back here to the example we had just a minute ago. If I wanted to sum the sum of the first 3 terms, okay, we can do that pretty easily. 7 plus 10 plus 13, right? So 7 and 13 is 20 plus 10, that's a 30. So the sum of the first 3 terms is a 30. Okay, that's easy when it's 3, no problem. But unfortunately, they're not going to be that nice to us. They're not just going to have us doing just 3 terms, right? So I might have to sum the first 20 terms or something like that. So this becomes really ugly really quickly. Okay, so really big numbers if I have a lot of positives, or like this one with a negative, I'd have really big negative numbers if I started adding. The first term was 4. The second term is negative 3. Okay, 4 plus negative 3, that's negative 1. But we just said the third term was negative 10. So 1 minus 10, I'm at negative 9 now. When I start summing things up, I start adding up pretty quickly. Okay, so what we have is there's a summation formula, basically. So the summation formula looks like we're going to take the sum, and again, I'll talk about this in a second. S sub n is equal to n over 2 times a sub 1 plus a sub n. Okay, so basically what they're saying is, if you want to sum the first n terms, you want to sum up the first n terms, then you take the number of terms you have and divide by 2, okay, because it's going to be an interesting pairing thing going on. And then this is still my initial term. Okay. Initial term, and the a sub n is still my, in this case, it's the last term, right? It's the nth term. But if I'm only summing the first through the nth term, sum the first nth terms, then this will be the last one in my sequence. So let's do the one I just showed you a second ago, where we had, sorry, it was 7, 10, 13, 16, 19. That was my sequence from above, right? That's the one that we had just a minute ago. Okay. So if I've got that sequence, we added up the first 3. So hopefully my formula will work for me. Okay. It says if you want to add the first 3 terms, summation of the 3, let me put it here so we can see the formula. There you go. Sorry. If I want to add the first 3 terms, then I'm going to take the n, which I said 3 terms, so 3 divided by 2. And I'm going to put in there, in here, in the parentheses, the first term. The initial guy was a 7, plus we said the nth term, well, the third one is the 13, right? Okay. So I've got to add that stuff together. So work your PEMDAS, make sure you're working it in the correct order. This is 7 plus 13 is 20. So I do the parentheses first. And then I'm going to multiply. It's really 20 over 1, right? So 3 times 20 is 60. Divide by 2. And look at that. I get a 30. Okay, which is exactly what we did. We said it was going to be whenever we did the notation a second ago. So I'm almost out of time. I'm running up against 40 minutes. So I just want to show you real quickly the notation for that because it's going to look a little different whenever you see it in the homework. They have this interesting summation symbol. So let me give you that. Okay, here's what it looks like. And I'll explain the I in a second. This sigma, that's a Greek letter, capital Greek letter. It means summation in math. And it's I equals 1 to n. Okay, because we're doing the nth, guys. Okay, of whatever a sub I I'm looking for. Okay. So for instance, if I want to do that, if I want to sum that up, then what this means is substitute in. The I means increments. Okay. So we're going to increment this guy. Okay. So what they're telling me to do is find the first guy because we start at 1, I equals 1 up to whatever the n guy is. So a sub 1 plus, and then we start incrementing. So in consecutive whole numbers. So the next guy is going to be the 2, right? 1 and then 2, a sub 2, plus the next guy is a sub 3, plus the next guy is a sub 4, plus the next guy is a sub 5, plus ... until I get to whatever number is on top of this summation symbol, this sigma, and that happens to be an n. So I'm going to go in a sub n. So this notation right here is count by ones. That's what that means. From, I'm going to put that here, from this number up to this number, and this sigma again means sum, okay, or add, okay. So it's just an interesting notation that they give us, and you just have to see it. So real quickly, one example of what this would look like. This is an example out of your book. It says they want me to find the sum I equals 1 to 25, which means we would start counting the first term, the second term, the third term, and so on. And the sequence that they want me to use is 5i minus 9. Now notice that when they start using this notation, sometimes they change from n's to talk about i's, but this is still going to be the same thing. The I here represents what position I'm in, what slot am I looking at. Okay, so I can come through here and go, well, 5 times 1 is 5 minus 4. So that's going to be -4. 5 times 2 is 10. Oh, I'm sorry, not comma plus. Okay, 5 times 2 is 10. Minus 9 is a 1. Okay, plus 5 times 3 is 15. Minus 9. That's a 6 plus, and I've got to do this all the way up until I get to 25. That's a lot of terms there, right? Okay. So whenever I see that, I'm like, oh my gosh, up till I get to the 25th guy. I'm sorry. 5 times 25 is 125. 125 minus 9 is 114. Okay, so that's my a sub 25th guy. This was my a sub first and my a sub second, and so on, right? Okay, sorry, I had to do that math in my head. Okay, so what we're going to say here is this is going to get a little bit messy pretty quickly, and so I don't want to add all that stuff up. Instead, I could use the formula we just talked about, right? Okay, the sum of the nth terms, first n terms, is going to be n over 2 times the first guy plus the last guy. Okay, so again, I need to find the first guy and I need to find the 25th guy, but did I need to find this third guy? No, not for the formula's sake. For sake of seeing my pattern, maybe you need to find that, but for the formula, not so much. So what this is telling me is find the sum of the first 25 guys, right? N is 25, 25 over 2. What was my a sub 1? We said it was -4. And what was my a sub n? I'm pretty sure about that math, but check me, 114. Okay, so that's 25 over 2 times, and I'm going to make this over 1. 114 minus 4 is 110. Okay, I'm going to reduce that. That's going to be 55. And goodness, I don't know what 25 times 55 is. So I'm going to leave it just like that. And oh, hang on. I think I do have the answer. Let me check because this is in the book somewhere. I think it's 1400. Nope. I don't know what that answer is. So you can do the math on that and figure out, oh, sorry, 25 times 55. What are we looking at there? Okay. So we didn't finish out geometric. I'll have to do a separate video of that, but I'm already over the time I normally allot. So thank you for listening, and I hope this all makes sense. Let me know if you have questions. Thanks. Bye.